This is Jack Jackson back with some more looking at some transformations. Today we're going to talk about rotations. Now, in general, a general rotation, I should say rotation, requires that we specify a point, which is called the center of the rotation, and some angle of rotation. We then move the pre-image points along a path, part of a circular path, to the image point, so that the image and pre-image points are the same distance from the center point, and the angle from pre-image to center to image is the angle of rotation. In general, we perform two reflections about intersecting lines. The net result is a reflection about the intersection of two lines through an angle twice as big as the angle between the two lines. Therefore, if we reflect both about the y-axis and the x-axis in either order, the net result is a rotation of pi radians, 180 degrees, about the origin. So general reflections and general rotations require the use of trigonometry. And my trigonometry notes do go over some of this in more generality, but here I just want to specifically look at one specific rotation. Rotation by pi radians, or 180 degrees, about the origin. Now, in general, when you take any rotation, it's congruent to its original, to the original pre-image. And all distances and angles in the image are the same as the corresponding measurements in the pre-image. The image is exactly the same in size and shape as the original image, but its orientation has been rotated. The only fixed point in a rotation is the center of the rotation, but you could have the points collectively be the same, and that would, of course, be symmetry about for that rotational symmetry. Okay, so specifically, if we want to do a 180 degree or pi radian rotation about the origin, we need to reflect over both the x and y axes. So you need to replace x by minus x and y by minus y, both. And that will give you a half circle turn, basically. So if we take y equals x squared and replace y by minus y and x by minus x, then you can see that's what we've done in the table here. For example, negative 3, 9, we've replaced the negative 3 by positive 3, the 9 by negative 9. And so what we can see is the image has been rotated 180 degrees. So what was up here, say at 3, 9, is now down here at negative 3, negative 9. And what was at negative 3, positive 9 is rotated 180 degrees down here to positive 3, negative 9. Now, it turns out that if you take y equals x cubed, we change both the x and x to negative x and y to negative y. Three negatives multiplied together makes a negative, and you can divide both sides by negative 1, and that reduces back to the same formula. So what that tells us is that even though 0, 0 is the only fixed point, every other point moves by changing both the x and y coordinates. You'll see that this is the same table reordered, and the graph is the same graph reordered. So even though we rotate 180 degrees about the origin, we get the same graph. And so that's symmetry with respect to that rotation. And when we're talking about 180 degree symmetry about a point, we say that has symmetry about that point, so that we call this origin symmetry.